Here we are asked to write the equations for the piecewise function. Just take each piece and figure out what the equation would be. Now these are all linear pieces, and I have some different tools I could use for something like this. So let's just think about it for a moment. We're going to want some of these linear equations, forms and formulas. So I'm going to just kind of jog my memory. So linear equations, we have a few different things. We have the one that everybody is most familiar with, the slope-intercept form of a line, which is y equals mx plus b. We have the slope formula, so for just finding the slope, we have m equals y2 minus y1 over x2 minus x1, or in other words, rise over run. And we have the point slope formula. So named because it's great for using when you have a point and a slope available, and that point is not a y-intercept. Not that it wouldn't work if it was a y-intercept, but if we had the y-intercept and the slope, this would be the easiest one to use. And so if we have the slope but another point that's not the y-intercept, then we would probably want to go here to use the point slope form. And still there's the standard form, which is often written as ax plus by equals c. And we really like that form. So if we were working with this form and we were going to graph it, it would be really useful for finding the intercepts and connecting the two places that the line crosses each axis. So for this one, I think we're going to be using point slope formula because it's going to be easy for me to grab a point from each piece, and then I can visually count rise over run. So I'm going to do, that's going to be my approach. There are other ways I could do this, but that's the way that jumps out at me and seems to be like it's going to be the most efficient. Okay, so let's start with this point here. So usually you start with the piece farthest to the left, and that's going to go in the top box, because notice that for each piece you have certain x values, an interval of x values, where it's going to, the function is going to follow whatever rule we put into the box whenever we get an x value in this interval, right? And that you'll notice that these x intervals for each piece are increasing as we go from top to bottom. And of course, on the graph, the x values are increasing starting from left to right. So that's why I picked that farthest piece to the left for my top box. All right, now another way you can tell is x is equal to -6 right here. Okay, so this whole grid line that goes through where x equals -6, and also this grid line going through where x equals -2. Notice that that is all the section that that first piece covers, right? Okay. So with that in mind, I've got my first ordered pair here, and it doesn't matter which point I choose. I really can pick any one I want anywhere on the line, but I'll just go ahead with that one, and that is at -6 for x and 1 for y. And now I'm going to visually figure out my rise over run. So I can go to any other point on the line, like I said. I could go to this point, and that would mean up 1 and over 1. So if my rise is up 1 over 1, 1 divided by 1 is 1. Or let's say I wanted to go all the way to this point from that first point. I would count 1, 2, 3, 4, and then over 1, 2, 3, 4. And so I would have a rise of 4 divided by a rise of 4, right? So either way, I'm getting a slope of 1. So I'm just going to write that first. Like I said, I'm going to be using this point slope formula here. So y minus y1 equals 1 is my slope, x minus x1. Now, you could do it the long way and get another set of ordered pairs, like this one that goes through negative 2 comma 5, and you could go and put it into this formula right here. And you would find that when you finish doing all that work, you'll get 1 again for the slope, all right? So I'm just using the visual way because it's convenient for me to do so in this picture. It's the fastest approach. All right, now I'm going to also plug in my y1 and my x1. Doesn't matter which point I use, but I'm just going to keep the other y variable, just y, and this x variable is just going to be x, okay, and I've already got my slope. And so now I'm just putting in my y1 and my x1. So y1 is negative 6. Okay, that double negative is going to become a positive. Oh, I'm sorry. That's supposed to be 1 for y. The negative 6 goes over here because that's the x value, and there the double negative is going to become positive. And then we have y minus 1 equals, if you distribute this 1, it's not going to change anything inside of the parentheses, so I'm just going to have x plus 6. Then what I want to do before I can put anything in this box, in this answer box here, because the answer box over here in front of it, it has f of x equals. So that means that I need to replace, in my mind, I want to replace f of x with y so that I can realize I need to solve for y. I need to get y alone on one side of the equals so that I can write this in function form. So then I have y is equal to x plus 7. So that's my first piece. All right, now we'll go on and write the second piece. So we already have x plus 7 for the first piece. And now we're starting to focus on the middle piece. Now notice, the middle piece is a horizontal line, and no matter which point you pick, you're going to notice something in common with all the points, and that is that the x value can be anything between -2, but not including -2, just starting at -2 and greater, and up to and including 3, because it's a closed dot there. Open circle means you don't include the -2, closed dot means you do include the 3. So notice that this piece says it's from -2, not including it, and less than or equal, including 3, right? So that's the piece we're working on right there. But as long as we pick an x value in that interval, the y value is always the same. The y value is always 4, right? Any point I pick here, this one would be 1 comma 4, this one would be -1 comma 4, and so on. So the only rule is that y always has to be 4, and we have to stay in this interval, okay? All right, so now we're ready to move on to the next piece. Convenient, right? That's simple. Well, actually, let me back up for a second. What if you didn't realize that? What if you didn't know that was the case? Is there another way you could have figured it out? Absolutely. Okay, so let's talk about another way you could approach this. So before, I was using the point slope form, right? So the point slope form, y minus y1 equals m times x minus x1. What did I do? I chose an ordered pair on the, doesn't matter which one, I'll just pick any. So I'll do 3 comma 4, and then I'm just going to replace the y with 4 in my point slope formula and replace the x1 with 3. Then if I want to find my slope, I can do rise over run from one point to any other point. So if I wanted to go to this point, from this point over, say, this point, what would be my rise? I wouldn't go up at all, right? So then actually my rise is simply 0. Don't rise at all. And then the run, if I was going from this point to say this point, how many would I run? 1, 2, 3. Does it matter? No. I could pick any point and it could be any amount of run. And the same thing would happen in the end, is 0 divided by 0, or sorry, 0 divided by a number is going to give you 0, right? So here my slope is 0. So in this next step, I'm just going to replace the slope with 0. Now what happens when I do 0 times this quantity? The whole thing becomes 0. You know, anytime you multiply something by 0, you get 0. Now finally, I'm going to solve it so that y is alone on one side of the equals, so I can write this in function form. So I get y equals 4, and then replace that with f of x equals 4. Okay, now the next part. For this last one, do purple, and I'm going to do the same approach. I'm going to use my point slope formula. I'm just going to grab any point. Why not use this one? That one is starting at 3, 3. So I will go ahead and replace the x1 and y1 with those coordinates. Now I'm going to visually find the rise over run to get the slope. And it doesn't matter what other point I pick, but I just want to pick one that is going through to the intersection of 2 grid lines. So I don't like this one because it's not on an intersection of grid lines. I think I'll use this one instead. So now to get from the first point to there, I can count down. And when I count down from the first point, I would go down 1, 2, 3, and then I'm going to go to the right 1, 2. So because I went down for the rise, I'm going to make that a negative, what was it, 1, 2, 3, yeah, negative 3. And the run, I was moving in the positive direction for x, so that is going to be a positive 2. So now I can replace the slope with negative 3 halves. And once again, I'm going to want to solve for y. Now, you might be able to get away with just adding 3 like that to both sides and not simplifying it. The computer might mark it correctly, but it's really not meant to be like that. I mean, it's not good practice, and you know, certain teachers might take off points for that. So I'm going to teach how to do it the right way. So I'm going to distribute first the 3 halves times x, or sorry, the negative 3 halves times x, which will give us negative 3 halves times x. Then negative 3 halves times positive 3. And I'm going to just write this over here, negative 3 halves times 3 over 1. And then multiplying straight across, I'll have negative 9 divided by 2. But it was, sorry, a negative 3. Yeah, so this will actually be a positive 9 halves. Okay. So just have some little thought bubbles over here. Now I'm ready to solve by adding 3 to both sides. Okay. But time for another little thought bubble. We're going to do the 9/2 plus 3/1. And then when you're adding fractions, you need a common denominator. So you're going to want to do multiply. I'm going to multiply 3 times 1. But instead of writing it as 1, I'm going to write it as 2/2. That color's just not working for me. Hold on, let me get a better one. Need a better color. Let's see. How about this one? Okay, we'll try that. I'm going to multiply 3 times 1. But instead of writing it as just 1, I'm going to write it as 1/2. Sorry, not 1/2, 2/2, 2/2, because 2/2, 2 divided by 2 is still 1. And then I can multiply straight across so that I can rewrite that as 6/2, right? And notice that 6 divided by 2 is indeed 3, which is what I originally had. So now that I have the common denominator, I'm going to add the numerators together to get 15/2. So now I have y equals -3/2 times x plus 15/2. And that's what's going to go in that last box. Okay, so the first piece again was x plus 7. The second piece was just 4. And the third piece is -3/2 x plus 15/2. Right? So notice I'm not writing y equals, and I'm not writing even f of x equals, because that's accounted for over here. And usually we don't see each of these brackets. That looks kind of funny. It's usually just one big bracket, one big curly bracket to show that f of x is all 3 of these pieces. And the way you figure out which rule to use when you're coming up with an ordered pair based on a chosen x value is you look at where the x value falls. If it falls into this interval, you're going to use this rule. If it falls into this interval, you'll use this rule, and so on. So for instance, if I said let x equal 1, then that would fall into this interval. So I would have the ordered pair of 1, 4. But if I let x equal 4, okay, then how would I get my y value? I would use this piece, right? So I would have -3/2 times 4 plus 15/2. This would become -6 plus 15/2, which equals -12/2 plus 15/2. So that would be 3/2. Now notice that, oh, I guess I'll do one more. I'll do one for this piece. So let's choose an x in this interval. This interval, we could choose, say, -5 for this one, okay? So if I do -5 for x, how am I going to get my my y value? I will put f of -5 is going to be -5 plus 7, which is going to be 2. So that'll give me that ordered pair. Now notice that 1, 4 is right here, right? So it fell right on that piece. And 4 and 3/2, which is the same thing as 4 and 1.5, or 1.5. I go to 4 for x and 1.5, I'm right there. Okay, so that was that piece. And then for x equals -5, 2, -5, 2. There it is.